this one, we have a variable amplitude here that's an exponential function. So what we should find out when we graph this later is that the wave is going to just keep getting taller as we move away from the origin. To find the values for A, B, and C, it's just substituting in X and Y as a point. And in the order they're given should work just fine. So I'm going to call this f of x. And so the first point says that f of 0 is 4. And if we plug in 0, we'll get a times b to the 0 times the cosine of pi over 2x. Oh, x is 0. Plus c. All right, what do we know? Let's see, b to the 0 is going to be almost 1. Yeah, a non-zero number to the power 0 is 1. Cosine at 0 is also 1. So we get a times 1 times 1, which is a, plus c equals 4. So unlike the previous problems we tried, we don't get an immediate number on one of those. So we try another point. F of 1 should equal 1 versus a times b to the 1 times the cosine of pi over 2 times 1, which is pi over 2, plus c. Okay, let's see. B to the 1 is just b, not much to do with that. Cosine of pi over 2 is 0. Okay, so all this is gone because the cosine is 0. Hey, we scored a number. We got c equals 1. That allows us to backtrack over here. So now I've got 4 equals a plus 1. Subtracting that 1, I get a equals 3. All right, making progress. The next point should be able to get a final value. So plugging in 2, f of 2, according to the table, should equal negative 11. And we just discovered that a is 3, so this is going to be equal to 3 times b power 2. Don't know b yet. Times the cosine of pi over 2 times 2. And we know that c is 1. Okay, cosine at pi is, sweep around pi 180 degrees. The x value on the unit circle there is negative 1. This right here is negative 1. Cleaning that up a little bit. We have negative 11 equals 3 times negative 1 times b squared. So negative 3b squared plus 1. And we can clean that up a little bit by, say, subtracting this 1 to the other side. So I'm going to write it as negative 3b squared equals negative 12. I can then divide by negative 3. B squared is 4. And so then b is plus or minus the square root of 4 is plus or minus 2. So we'll have to make a decision next about which one it is. plus or minus. I am going to guess it's plus because a negative base with a exponent leads to imaginary numbers. And that's a problem. Okay. So I am 99.5% certain it's got to be the positive one because it's the base of an exponential function. So let's write that down and test it with the next point. So at this point, we think f of x is a equals 3, b equals 2, that's to the x, times the cosine of pi over 2x, then plus 1. The last point is 3, 1, excuse me. We want to check on point 3, 1. So f of 3 would be 3 times 2 to the 3rd times the cosine of pi over 2 times 3, then plus 1. Okay, cosine of 3 pi over 2, 3/4 the way around the unit circle, the x value is 0. We're going to have 0 times all of this, plus 1 is 1, which does check. Now, again, that didn't really test my claim about the negative here, but if you try to graph something like -2 to the x, that works well for some x values and not for others. For example, if x was 1/2, that would be the square root of -2, which is imaginary, which we can't graph on the xy plane. So this is unlikely part of the solution. Boom, done. There is our function. And again, a good thing to do next would be to whip out Desmos, graph this, and check at x equals 0, 1, 2, 3, and 4 that we get the same y values we expected. Pretty likely that we will, but it's always a good idea to double check.